Hello, a very good morning to everybody. In this particular session, we are going to see, the certain things about the deep excavations and checking and all. We'll take certain case studies. If you remember yesterday also, during the last session also, we have taken certain case studies. Okay, so before making it due today, actually, let's get started. Now, this is a case study of 55-story building in Mumbai, and how actually the excavation work and the shoring system and the foundation work actually it has been started. That is what actually this entire photographs and the projects are there. This is actually this project is we have given the as a Econstruct actually we have given the consultancy to this project. So I'll just show you. So this is the first photograph. Actually the excavation is not started. These are the neighboring buildings. There are 3 basements. So you can see that if you want to construct the 3 basements, you will see that how the neighboring buildings need to be protected. You have to protect the neighboring buildings for sure, right? So this is how actually we will look into it, right? So let's go to the next one. So this is the next slide in which the excavation you can see, and there is this particular portion is known as the waterproofing. If you remember during the last session also I told you that you require certain waterproofing, membrane waterproofing is there, or maybe some people they are using the tar material as waterproofing. So there are varied variety of different options are there, but obviously you require the waterproofing so that till the time actually the raft gets constructed, or sometimes actually what happens is if the water is started coming, actually you will have the reinforcement laying here with certain spacing in this direction and all actually. So if there is a water here, the rusting will be started. So is it temporary phenomenon? No, it may not be the temporary. Later on also this waterproofing helps actually to give certain layer actually against the water that to get directly connected to the raft surface. So this is the waterproofing area that you require. Later on I'll show you the certain drawings also, so that you will understand what as a project manager, as a civil engineer, how you should be dealing with this on the site, right? Now the next one is the PCC. You can see that the people are doing the PCC here. Okay, so how the PCC, I mean here what all the things that you require. First of all, so you can see there are shoes where it has to be used by the laborers, plus on the hands also you require certain hand gloves. You require the helmet, because anything which is falling from this, actually let's say the stone or something, actually the person should not get hurt. So all these things are extremely important. If you look at this actually at this portion, what is this? This is basically some portion it is given for the, because the PCC or the raft is only up to this place. So you need not go for PCC at this level actually. So that's the reason this is the form work that has been given. Okay, so you can see that generally excavation and PCC or something, and this is Mumbai. So if for example if there is a rain, huge amount of problem comes up. So generally if you see that any major excavation activity, particularly in Mumbai or Chennai or those kind of areas, the developer builders, they start working with a very very high speed, so that later on there should not be any problem. Now this PCC and all actually it has been done, but you can also see that over here the retaining wall is constructed. You can see that the construction of the retaining wall is over to certain extent. All right, so let's go to the next one. Now here this guy is doing something. Now what is it doing, and what is this? So I would like to just show you that This is the shoring pile. Okay, this is a retaining wall. Now, retaining wall also, it has been constructed or casted in different phase. You can see that this is one phase of construction. So let's say this is the first phase of construction, this is the second phase of construction, means the casting, the third phase of casting, and the fourth phase of casting. Okay, and there are certain markups of the levels. What is this markup? Is levels. Yeah, so this is how actually you will give the you will try to monitor certain things. Now let's say next one, why actually you need to monitor is also, it's very important. So I'll just show you a few things actually. So let's say, for example, if you remember during the last session I had shown you that you require the PT strands to be the tension in the PT strands need to be removed. So obviously the markup of this is needed, that when exactly this particular phase it has been constructed and when the PT strands has to be released, because there is a that there is a tremendous pressure from this side and the PT strands will resist that pressure. Okay, so certain time bound activity it is, so you need to release it over the period of time. So to record at what is the date of construction and all, actually that is to be recorded properly, so that you know where actually you are, when and where you are constructing and what you are constructing. Right, now let's go to the next one. Okay, now what is this? This is the foundation load testing. If you remember, yesterday also I have shown you for India Tower. So somebody will say that, sir, that is India Tower, that's why people are doing, that is 130 story building, this is just 55 story building, half of that, less than that. So there also you can see that the foundation is constructed. It's not the real foundation of the building, it is the dummy foundation, but the grade of concrete, let's say thickness, grade of concrete, okay, everything has to be same as that as the raft. Why? Because it has to be simulated with that. So let's say, for example, you might have seen that if you want to test the rice whether it is cooked properly in your kitchen, what you will do is after some time actually you will take some piece of that and you will just take the sample. That is actually sampling method. So similarly here also you have to make sure that the same piece of the raft actually you are checking, and that's how the same thing it has been done. Now some of you might be wondering what the hell is this actually and what this guy is doing here. So I would like to just show you that this is the rod which is not connected to this raft or the piece of foundation. Alright, so what is it happening? This one is actually anchored here, and there is a instrumentation here, there is a calibration here for this. So whenever you are putting heavy load on this, some kind of settlement will be there. It will be reported in this and calibrated here, because this is in reference with what exactly is happening, and this is in reference with the foundation. I hope you are getting what I am saying. Okay, so this is how is it only at one end? No. Generally this is done at the 4 areas, 1, 2, 3, and the backside of this, the 4 areas. Okay, so if you are having a plan, actually this is the foundation, at the 4 corners actually we will be doing this, and there is a average, mean average, all these things would be recorded. Understood? So this is the foundation testing machine, in which it's not a plate load test. Okay, generally plate load test, the plate will be hardly You can go through certain YouTube videos or maybe certain photographs or something like that, how the SPT testing actually people are doing on the site. So this is not that, this is the foundation load testing machines or the procedure. This is little costly because you need to first of all construct this, you need to call these people actually, you need to give the pneumatic, you have to give this arrangement, there is instrumentation involved, there are people involved. So this is little bit more costly than the SPT, but the calibration if you are asking or the results that you are asking, far more advanced results you will be getting it here. This will take a little bit more time also. So if you are considering the time and what is the cost, that is money actually, here in both the cases the time will be higher, money will be also higher, but accuracy when it comes to the specifications, reliability and accuracy, okay, so all these things actually will be more over here, okay, in this kind of test. So that's why people are generally, for high-rise buildings, it is very much preferred to go for something like this. Alright, so this is the foundation testing load. So you can see that the pneumatic load, somebody will say, sir, how to give that much amount of load? You know, you don't need to construct the entire 50-story building, 55-story building to implant the load on this. Entire 55-story building is not resting on this, correct? This is just one column. So what you will do is, you will take the maximum dead load and live load. So what you need to ask is, dead load plus live load. How much is the dead load plus live load in the kilonewton? What is the maximum value of this? That value you need to implant it here. Understood? So whenever you are getting the foundation data or foundation drawing and all, actually you should ask that you please give these figures to you, so that you can give these figures to these people actually, and they will apply the same amount of load, okay, same amount of thickness of the raft is you are considering, and with the instrumentation actually your exercise will be more genuine. Understood? Right? During the college days or something, actually we were working only with the plate load test, PT values and the plate load testing and all actually. That is, it is okay for G plus covered 2-3 story building or maybe 4-5 story building, not for such kind of buildings. Okay. Now, what is this? This is the place where you can see that the PCC is laid already. People are doing, this is the pipe through which the RMC is getting transported. Here people are just doing certain work and resting, and some people actually, why? Because certain portion is already got concreted. So it's a heavy day. Generally concreting on the site is a very heavy day. So this is how it is. Some places you will see that the formwork it is given. So here this is the formwork. Alright. This one actually is the place where you can go out of the building. You can see that there is staircase actually. So to come down, you cannot just take a helicopter and come down, or take a rope and come down. It is very dangerous. So there is a proper steps. Also you need to wear the helmets and all actually. So what is this? This portion is the formwork. This portion is the formwork for constructing this shear wall or the retaining wall. Understood? Yeah. So once this phase is getting constructed, then you will go to the next. So this is the first phase, this is the second phase. So first phase is getting constructed here. Once this is done, then you will go to the second phase. Once the second phase gets over actually, then you are going to remove this. 1, 2, 3, 4. What are these actually? These are the PT strands. Understood? How to remove and all. It is just like, just like a screwdriver, something like that. You just need to remove this actually. The tractor, the backside tractor wheel is quite big actually. How to remove that? There are nut bolts. So you just need to unbolt certain things, and because there is a huge amount of pressure, you need to do it mechanically. You cannot do it with hand. Understood? So when to remove this is also important. Now let me tell you few things over here so that you can understand what I'm saying. So here, this is not the starting position of this, correct? If you go up, it is quite high, the height is quite big, and 1, 2, and it is going down also. So tremendous amount of pressure is there on these piles to come out of this, to come inside like this. To stop that activity, you have given the back support through this. So please stop. Okay. There is an anchor also down, that also will give you, so it is something like, you are having a pile here, and there is a tremendous amount of pressure is there from this side. So but from the other side you are giving the nails like this, you are giving the nails. So these are the nails. Okay, of course this is connected with the beam here. You can see that this is a beam, and at certain interval actually, now this is from here to here there is one spacing, from here to here there is another spacing, from here to here there is another spacing. So the equal spacing is given. Somebody was saying that, sir, what is the spacing between the two? You can see that there is no spacing. It is once this is casted, immediately next one is getting casted. We will not leave any space in between. Obviously, you have to have some space. Actually, Panchamahabhusha, you have to have some space, otherwise you cannot construct this. So space is created, generated, not allocated. Understood? So whenever the space is there, where you will see the space is there, actually, that place you will just, take, you will implant this at a certain distance. Alright, so this is how actually the deep excavations are getting carried out. Understood? And this is actually the shuttering work, and this is the construction. Now, when to remove this? Because this has to be removed because it is there in the neighboring building. Understood? So when to remove? Once this construction is getting here, actually, that time you are going to remove it. Why? Because this particular retaining structure will give the support to these piles. Do you agree? It will stop, the movement of the piles coming to the, your plot boundary. So this is how actually certain assumptions, certain techniques, certain instrumentation, certain works has been carried out with the safety, accuracy, and all actually. And on the top you can see that there is a pile beam is also there, so that all the piles are in one line. Otherwise, as I told you yesterday, suppose these fingers are the piles, one pile will be like this, one pile will be like this. So you cannot work with this. So all the piles should be there in one line so that you will have proper surface. Okay, this is the proper surface actually, and then you can do the construction work over here and you can start the building construction. So that's how it is. Understood? So this is how the case study actually of this. You can see that at some places you will see that the water is also peeping inside. Now this is very important. We call it as water wells. Means if the water is coming inside, what to do? You cannot stop this water. Many times you cannot stop it. This is the natural stream of water. Sometimes you hear also, you can see that the water is coming, water is coming, water is coming, water is coming. You cannot stop this. So what to do? You have to lay the passage in between so that the water can be, there will be a drainage system over here. Okay. It's like, you might have seen that in the agricultural area. Okay, so they will create a small passage, small canal, a very, very small canal kind of thing, from which where the water is going, and somewhere they will dig a little bit big. Actually, it is a well. Well means the water is stored there, and from that storage, actually, the water will be pumped outside. Understood? Sometimes if the water is less, actually it will be utilized for curing purpose. If it is very less, if the water is quantity is quite big, actually it will be pumped outside. For curing purpose and other purpose, you have to see the quality of the water. Do you know, I think the first year engineering you were having the subject called water. Okay, so what is the pH level, this one, the contents in the water, sulfate content is how much, this content is how much. So you should do if you are using the water for construction, whether it is for concreting, whether it is for curing, actually it is better to get it tested. It will take hardly less than a couple of ₹1,000 for testing, but you have to see that. Alright, so this is how actually this particular photograph will give you the information. Let's go to the next one. Now here you can see that the people have started working with the second stage of the concreting. So here the certain phases of, this is the retaining structure, the first phase of the retaining structure, this is the second phase of the retaining structure. This is the raft at the upper level, this is the raft at the lower level. This is basically the form work. This is the form work. Understood? Yeah. Here you can see the engineers, the project managers and all actually are giving certain suggestions and all actually. Here you can see that the laborers and all are there working. Understood? Here there is a first level of the PT strand. Can you see that? So why this cannot be constructed, why it is stopping only at this particular point? It is because this PT strand has not been removed. Understood? So the moment you have constructed, then you need to start removing this. You remove this, then you remove this, then again you remove this. Once this is done actually, then you can continue this operation this side. Also this operation this side. Got it? Now once, like for example, this is over, this second phase is over, this also has got removed, then you construct, then on the top also there is a second phase. Here also you can see that this is the second phase of the PT strand, that also need to be removed. Understood? That is a temporary structure that has to be removed. Alright, so I hope you are getting this. Now the next slide, this particular photograph is basically for the retaining wall and the retaining wall foundation structure. What does that mean? Is you can see that there is a bottom reinforcement of the raft which is getting laid over here. Now this is basically the tower building raft. This is basically the retaining wall foundation or retaining wall beam raft. So structurally this is the strip footing. Strip footing means it is like linear fashion footing. And this is like isolated footing. This is also isolated footing, which is combined inside the raft. This is the retaining wall reinforcement. Generally it is in two layers. Currently only single layer is going on. Similarly we will have the second layer. So that's what actually people are working over here. Understood? Now why we are constructing this? Because why we are not constructing at this place? Because initially you will construct the retaining wall first. This is the retaining wall has to go. Then this construction other areas has to go. Why it is like that? Because here you can see that the retaining wall to certain extent it is already getting constructed, and then you will do something like this over here. Understood? Sometimes you required some shotcreting material also here. So this can be the shotcreting. Shotcreting means what? They will create the passage which is little plain. Understood? It is like if you go to any salon and if you want to do shaving or something, actually he will spray some water on your face. Correct? So that kind of shotcreting means it is the spray of not water, it is the spray of the concrete will be done on the surface like this, just to make the surface plain, and then the reinforcement would be carried out, and then the retaining wall construction would be carried out. So that is basically the sequence. On this directly the retaining wall construction cannot be done, because on the other side, on that side of the retaining wall, it is very muddy land. It is not a proper surface actually. In order to create the proper surface, this sort of shotcreting can be done. All these photographs are of this same building, so don't get confused. Now here, this is the phase wise. So here you can see that the second phase of the PT strands has not been removed. Also you can see that there is no retaining wall structure, also it has been finished. But here you can see that the shotcreting and as well as the retaining structure has already finished, right? And now people are working with something else now. Got it? These are the supports need to be given so that these things are not coming out. That's why the supports are given. Understood? So this is quite heavy work actually. You have to plan it out properly. How many labors you require, how much is the material that you required, how many pipes or steel, the formwork systems that you required. The reinforcement, how are you going to keep the reinforcement and all, how many rebars. See here, the rebars are given over here. The PT strands also, this is the PT strands. So there would be different vendors for different traces. So vendor management, it's a hardcore construction management. Okay, so there are dependencies, activities are there actually. Okay, and many places I have seen that people are I want to work as a planning engineer. So many people, they see that. So I'll just show you. I'll just take a boulder, this thing. So let's say this is one line, this is another line, this is third line, this is the fourth line and all actually. And later on you will see that there are certain, the dependencies. This is like this. Okay, so you will see that not like this, it will be something like this. A stylish arrow will be given. So these are bar charts, Gantt charts and all actually. So these are everything, this has to be there in your head. Understood? So what next? What next? What next? Then what next? Understood? So other people are working on the bar chart now, which is little bit micro level analysis, but macro level is already there inside. Many times, you are the director of the movie which is going on, actually the project on the site. The movie is just the film. There is no reality. Once it is shot, matter is over. Here it is not like that. It is the concrete reality. That's why this is known as, I'll just write down here. Am I right? What is it known as? Real estate. Other places it's not real. They don't call it as real estate. This is the only place everybody call it as it's a real estate. Others are like balloons. Today they are there, tomorrow IT, something, server gone, this gone, program got crashed. All these things will be happening. But this is the real estate. Right? That's why this is having incredible value. If you see that any country or something actually, how many buildings are there, how many monuments are there, how much amount of infrastructure is there, that will create the real value of the GDP, and many other things are dependent on that. So this is the real estate, right? So more and more you start believing in this kind of things actually, more and more you will see it. I got 5 flats, I got this much land, that's the real estate. I got this software, but today it is there, tomorrow I don't know. It might be crashed, some better software will come, upgradation you require, ifs and buts are there. Okay, imagine that I created one software. We are also developing the EPMC software, you know that actually. Tomorrow better software will come, another better software. That's not the real estate. This is the construction of this is the real estate. Right. Okay, so let's go to the next. Yes, why actually we are doing this and what are the different phases? So here you can see that, so this is the neighboring building. So if you start digging, actually the soil will start coming down from here to here. Along with that, the building also will come down from here to here. Of course, you don't want to do that. So that's the reason we are giving this kind of protection systems, 2-3 layers. So the first protection layer is this one. What is this? So that any drinking fellow doesn't come and fall down, any dogs, cats or something, actually some persons also, or maybe some small kids actually, what is happening here, they will just peep in inside and they might fall down. That should not happen. So this is the first preliminary level of the protection. That is also important. This is also, later on it can be used as a compound wall if you want to. But generally it is given as a temporary. Unless and until you are very sure that this can be used as a compound wall later on, then you can construct it as a RCC wall. Now the second layer, here you can see that there is a small passage because every plot will have a setback distance to a certain extent. So there is small passage, and then you will see that there are the shoring piles, there is shoring beam is there actually, which is pile beam here, and then as you know that this is the entire beam, this is the place where you will have the PT strands. From here you can see that the water is coming out. Okay, so this is little bit more wider view, so that I'm just repeating this. And this is the retaining wall structure which is going the different phases. Understood? So this slide is going to help you to understand this is entire, all this money that we are putting only to protect the neighboring plot. And imagine that there is no neighboring plot actually. We would have taken some 45-degree slope actually and matter is over. You don't need to go further this kind of shoring structure at all. Got it? So early stage construction also got certain advantages. Please understand. So suppose actually if a plot is there, actually nobody else, neighboring people actually not constructed. So it's good actually. You can start it immediately. If the neighboring people have bought the land and they want to construct, you can talk to them and you can have some 45 degrees. So you can save a lot of money, not 1 or 2 lakhs. You can save crores of rupees of money. Understood? So it's a very big money. Also the time. Got it? So there are early construction, there are certain advantages are also there. You will get little less price, but at least the foundation and the basements and all you should finish as early as possible. Alright, so this is what you have studied from here. Yeah, so this is really early stage of doing the, before doing the PCC, you can see the height of the person, how it is, and you can see that how big it would be. So this is how it is. So you can see that the piles are going below. This is the first layer, this is the second layer and all actually. So the things are getting worked out. This is all the PCC. Got it? Okay, so this guy is going actually the same, it is a similar slide. Alright, so these are certain photographs which I wanted to show you. Few more are there actually. Now what is this? This is the real work. This is the raft. This is the top reinforcement and this is the bottom reinforcement. These are the shear walls. These are the people actually who are working inside the raft. The raft thickness is 3 meters. The height Actually, you can just look at the building where you are living now currently. Look at the ceiling. That is the depth of the foundation that we are dealing with. This is what actually, and you have to go inside to lay the reinforcement. There are many variety, actually the many layers, multiple layers of the reinforcement. What is the diameter of the rebar? It is 32 mm. Understood? What is this which is going straight? This one, this one, this one, this one, this one. We call it as the chair rebars. This, the function of this rebar to maintain the distance between this and this. It will maintain the particular height between the top jolly and the bottom jolly, or top mesh reinforcement and the bottom mesh reinforcement. Design of this is also very important. You cannot give 12 mm bar, otherwise the bar will start buckling. Understood? Sometimes you require eye section also need to be given here. It is a bit more costly but more reliable. This will not lead to the buckling. So these kind of systems are using. Now what is this picture? This photograph is basically the bottom reinforcement. People are putting the rebars and all actually of the bottom reinforcements and all. This is the top rebar. Okay, and you can see that the top rebar, how people are working on it, the top rebars and all. Here you can see that still certain works are going on, which is related to the the shoring system as well as the the retaining wall and all. So activities are simultaneously going on. This activity is also going on, this activity is also going on. Understood? Yes. So this is how actually the deep foundations or such kind of things, excavation. Now everything has began with actually what is basically the different excavation checklist is there. We were there in the surveying, authorization, earthworks. So we were there in the checklist. So I'll just show you. I have given the entire picture actually. Now coming to the documentation. Now this is just the documentation. Alright. So approval of the starting excavation, yes or no. Then you will have the drawings required. Do you have the drawings, yes or no? Equipments available. Do you have all the equipments available? Location of the disposing the excavated soil, where you can dump the soil. You cannot dump it on the road, right? Otherwise there would be a different problems. Labors required. Do you have the sufficient amount of labors required? Dewatering requirement. So that's the welling and taking the small canal actually, and the wells and the pump over there. Okay, so this is input check. Now the next one is process. In the process you will see that classification of soil excavated will be noted. Yes. Then any change in type of soil will be noted and got inspected. Shoring or benching should be provided if required. Okay, so this is the process. Okay, and as a civil engineer, as a project manager, you should be a little bit process person. You do the work, but are you going in a proper channel, proper process? So records of dewatering measurements, then hard rock will be properly stacked as per the requirement of the measurements. Then measurement sheet will be prepared. Okay, and safety barricades will be provided if required. Output. What is output? This is basically excavation will be checked for verticality. Verticality means excavation has to be checked like this. If it is sloped like this, then it is a problem later on. So this is verticality. So the plumb and all, actually the gravity, and that way actually will be checking. The next one actually shoring, benching when it is required to be checked and all. Backfilling. This is basically the backfilling. Okay, so backfilling authorization shall be obtained. So once everything is over, now shall we start the backfilling? In this case, there is a basement, so there is no black backfilling required. At some places, it might be required also, so we need to check that as well. So backfill check, material check. Which particular material are you dumping the rotten kachra material? No, you have to use the proper material so that it doesn't get decomposed. So later on, otherwise it will be creating a lot of problems. So proper backfilling material also need to be proper. Another thing is the backfill should be laid in the layers and the compaction is required. Yes, if it is yes, then yes. If it is no, no. Output. In situ compaction density inspection report would be prepared. So compaction layer for the backfilling material also you require sometimes. So is it yes or no? So this is what actually the checklist. Now some of you were wondering that, sir, can you give me this spreadsheet or something like that? In the EPMC we have already having this particular spreadsheet incorporated. Please go through that. Excavation 15 number is this particular spreadsheets. I mean the sheet. Alright, so I hope you might have understood certain things about the first starting work actually of the excavations and all. I would like to request you that if you can just go to the deep foundations, and there are certain other videos and all also there. Actually just watch through the YouTube or some other areas and all. I would like to tell you that the diaphragm wall is something that we are going to discuss about it maybe in the upcoming sessions actually. Maybe on Monday we will start working with the with that, what is basically the another phase of the deep foundations, because these 2-3 things are extremely important. Once the deep excavation, foundation, raft or maybe piles and all, once it is done, actually the upper level, once first floor over second floor, this is more repetitive work. There is no big fancy works that is required. Okay, but still certain checks are definitely required that we are going to check anyway. But apart from that, actually as a civil engineer, as a project manager, what are the checks that you require for the deep excavation and all? We'll look into it in the further upcoming sessions. So we'll take certain doubt clearing sessions now. Okay, you can unmute your mic if you want to ask certain doubts. Please put on your camera. Thank you. Yes, any doubts, anything? Ajit, you want to say something? How was it? Ajit, what? Raipure. Yes.
It was good, sir.
Good, okay.
Sir, these types of constructions, are they using mat and ground foundation or pile foundation?
Yeah, see, currently we are in this particular project which I have shown you, that actually we have constructed it is a raft foundation at the base, but to go that many deep down, actually we have to have the shoring piles. Okay, so shoring piles also are required to make sure that the neighboring buildings, I have shown you the photograph before construction gets started, correct? So neighboring buildings are there, and the shape of the neighboring buildings are also like any time that building will come down. Okay, because that is so old actually, but still because of this excavation, if the building comes down, actually there will be a legal case. Do you agree? Imagine that that's your house and somebody else is demolishing your house. Even if you are not staying there, it will be a very big case. You will make sure that the neighboring building will not be started. Why? Because there are certain emotional values, sentimental values, and many other things are involved into it. So you need to protect. That's your legal and professional duty basically. Right. So in the project we have done the foundation, which is the raft foundation, but the piles are only the shoring piles, just to protect the shoring structure. Okay, Sumit. Yes. Yeah. Anybody else?
Sir, instead of pouring pile, we can take the seed pile also.
Yes, secant piles are there. And diaphragm walls are there. We'll take the other types of shoring structures also into consideration. Yeah. Yes. Anybody else? Yeah, Aheli, you were saying something.
Sir, when presentation प्रेजेंटेशन में देख रही थी कि नीचे जेसीबी और ऐसे वाले इक्विपमेंट्स रखे हुए थे, उसको कैसे नीचे लेकर गए थे, लाइक
हाँ.
humans were going by the staircase, I get it, but
Yes.
how was the equipment?
Yes. So I think I have explained that. You can watch the video later on. At one side, actually, there is a slope given. Okay. At one side of the project, actually, generally what we do is we will give the slope. So let us say that imagine that this is the plot boundary. Okay. And in the plot boundary you are having the retaining structure constructed at the two side, one side here, one side here. So what I will say, I will do is maybe I'll put the gray color. So this is basically the retaining structure. At one side, let's say at this place also it will be something like this. But at one side, this side, let's say, I will be giving some kind of space. So this is a slope. Okay, so that any vehicle will pass on to this. Okay, so let's say for example if there is a vehicle actually will be passed from here. So this is basically the slope. So this is the GL, which is the ground level, and this is the bottom level. So there is a slope. This is a slope. So what they will do is they will complete here, complete here, complete here, complete here, and then these things will be come out, and this portion will be the construction will be done a little later on. Got it? And this slope also sometimes it will be done exactly at the edge, or sometimes it will be done at this, so that this portion also will be finished. So only this portion, the small tiny portion, will be done after certain period of time. So that is what we call it as the construction sequence. Okay, because this portion is going to get held up. Why? Because you require certain equipment, machineries to go down and come up. Okay, so how much is the surface is getting blocked, because you cannot cast the raft at this particular portion. Okay, so in the I think yesterday's slide also actually I have tried to explain you that. I'm sure that I have shown you that which is the place, because the photograph has taken from the other angle actually, so that portion of the slope portion was not covered properly. Alright, okay, so thank you very much for your time and see you on Monday.